Hello everybody, this is Himanshu Rathore from Department of Mechanical Engineering from Arya College of Engineering and IT. Today we are going to discuss about topic preliminary design and detailed design of subject product development and launching. In our lecture number 3rd, we are going to cover topics are detailed design and component design. Now, what is compatibility? This is an important factor influencing material selection whenever more than one type of material is used in product or assembly. Consideration of the possibility of galvanic action is essential. Compatibility in product design. Many design systems include a power developing device, a motor, an engine, a human being at the load, and a power absorbing device, a pump, propeller. It is essential to determine an operating point from design system for which both the power developing device and power absorbing device will work. If a unique point is not obtained, the system will fail to function and it's deemed to be incompatible. Designer role is to determine the correct operation point, that is compatibility in product design. Example, in a ship driven by a gas turbine, efficient speed of propeller may be 1/100th of the turbine. Propeller displaces a large mass of seawater at a low speed. Turbines driven by high velocity gases of product of combustion of fuel. Between turbine shaft and our propeller are suitable gearing will have to be provided to reduce the speed of the propeller. It is called compatibility. Now, detailed design. The detailed design phase begins with the concept evolved in the preliminary design. Its purpose is to finish the engineering description of tested and producible design. Up to this point, the design project is characterized by great flexibility. Major changes in the concept could be accommodated without great financial losses. In the first two phases, such flexibility is essential because they are exploratory in nature, seeking to reveal an adequate range of possible solutions. In third phase, however, either exploration on a large scale must come to an end or a final decision for a particular design concept must be made. Now, process of detailed design of subsystem. First step, preparation of design. In order to go ahead, we need budget approval and strong design team. The commitment to proceed is not final because relatively close estimate of time and money are needed prior to the design. The final economic success of the project can make the decision to suspend the project. The art and science of estimation is very important. Second step is overall design of subsystem. In the preliminary design, we are connected with the overall concept. Subsystems are examined only to evaluate the quality of the overall subsystem concept. Each subsystem must be looked as an individual entity. Compatibility of one system with other also needs to be verified. Third, overall design of component. The work which is required for the overall design of component is practically a repetition of what has been indicated for the subsystem. Just as a subsystem comprises several subsystems, so the subsystem usually comprises a certain number of components which are developed in the same way as the subsystem. Some of the components can be purchased as a complete assemble of hardware. Fourth, detailed design of the part. Part are the elementary pieces from which components are assembled. It is here in the work of designing parts that we come to grips with the concrete realities of hardwares. In the design of such system, a large number of relatively minor questions about achieving physical realization are allowed to the unanswered because we feel very sure that answer will come from knowledge and from available technology when the parts are being designed. Preparation of assembly drawing. After the constituent parts have been designed, the form of component can be fixed. The provision layout of the component can now be replaced by tentative final assembly drawing in case of incompatibility and oversight the compatibility which generally revealed. The affected parts suitably modified. After the component assemblies are prepared, the corresponding assembly drawings for the subsystem can be drafted. The final assembly for the subsystem is similarly undertaken. Now, sixth step is experimental construction. The completed drawing at hand, the prototype can be undertaken to build. The first full-scale prototypes. Sometimes the first prototype is also the end product. Seventh, product test program. The programs can be expensive if they are improperly planned, insufficient evidence against the design. They provide sent information on suitable revision can be based. Factorial experiment provide a very effective method of testing with low cost. In this method, the independent variables are changed between their high limit and low limit. Step 8. Analysis and prediction. With the notes and reports of experiment, construction, the data and the other general observation of the test program, preparation for the revision of redesign can be being if necessary. Now component design. One of the things that distinguishes component design from the design of ordinary modular system is that the component designer who don't know what other component will be connected to the product builders. Component design is therefore much more careful process than merely modular design. You have to make sure your component will work in a variety of contexts. Process of component design. The process of design is differentiated into three layers which may be performed by different people. Component architecture, in which you define the basics of how the components in the kit are coupled together and interoperate. Component design, the careful construction of components that can function in a variety of configuration and contexts. Product building, in which components are assembled to make working system. Now, process of component design. Component architecture. A component architecture or product line architecture is description for how component can be coupled, how they interoperate when platforms they work on. B. Component design. A component is something designed to work with a variety of other components, many of which are not known to its designer and in configuration determined by another designer. A kit of component is a collection possibly from many sources that are designed to the same basic architectures so that they can work with other members of the kit. C. Product building. The aim is to provide components that make product building rapid and low ceremony, requiring minimal construction of extra material. Thank you. That's all for lecture number 3.